thermal stress. The main objective of this project was to identify potential Caribbean coral thermal refuge sites where coral could sustain a substantial
Ethan, we're going to put this on for 5 minutes.
heterotrophic diet during bleaching events, with the end goal of increasing the efficiency in coral restoration. Anthropogenic greenhouse gases, particularly carbon dioxide emissions, have contributed to the deterioration of coral reef health worldwide. Climate models project that bleaching events will be more frequent and prolonged, leading to an increased mortality of coral reefs, in part due to starvation. However, corals are mixotrophic. A bleached coral can meet up to 100% of their daily metabolic requirements through heterotrophy. Coral reef refugia is an area that acts as a buffer to specific regional stressors. In the past, coral reef refugia sites have been identified by finding temperature-resistant loci. However, by adding zooplankton density to the mix, corals will be ensured nutrition during long bleaching events. "944 Caribbean coral reefs were identified by using reef base. These spatial points were utilized to extrapolate the sea surface temperature and zooplankton density. The model used for historical and future projections was GFDL's Earth System Model 4th generation, or ESM4. A model is an illustrative tool to represent a complex series of events. In this case, that complex series of events is the Earth system. The 4th generation ESM4 offers improvements in SST and includes cobalt. Cobalt is a marine biogeochemical model of intermediate complexity with daily outputs and includes 3 types of zooplankton. Using GFDL ESM4 allows us to advance our understanding on how the Earth's biogeochemical cycles impact coral stress and food availability. Degree heating weeks, or DHW, was the measurement used to quantify accumulated coral thermal stress. On the left is a simplified graph that depicts the DHW calculation. The thermal threshold, which you'll find as a red dotted line, is a numerical representation of what a normal summer temperature looks like for a Caribbean reef. Anything above the threshold is considered a degree heating week. Using exclusively ESM4 data, historical thermal thresholds were calculated. The steepest increase is found from the 1990s to present day, indicated the rapid rise of sea surface temperature. This figure is powerful because it demonstrates the new normal and the immense change coral reefs have undergone over the past few decades. In this figure, each line is an average climatology of 944 reefs in the Caribbean. The pink and green solid lines depict the historical SST and mesozooplankton density. Jumping into the future, we utilized ESM4 shared socioeconomic pathway 5. The pink and the green dotted lines depict the future of both these variables. This study aims to identify specific reefs that will futuristically have the lowest DHW and the highest mesozooplankton density within these averages. Out of the 944 reefs, the prime reef was determined to be Ground Bahamas, Bahamas, a location with high latitudes, cold water, and high mesozooplankton density due to high currents. In summary, using GFDL ESM4 model, we identified potential Caribbean coral refugia sites where coral could sustain a substantial heterotrophic diet during bleaching events. These newly identified refugia regions act as a safe haven for them to endure rapid change and maintain generational survivorship under harsh, anthropogenically influenced environmental conditions. Identifying coral thermal refugia sites will serve as a guide for distinguishing superior restoration sites, consequently increasing the likelihood of survival for restored corals. This methodology could be extremely helpful, but it must be more exact in practice. A fine-tuned biological web in Earth system models and a division of ecoregions could aid in providing more accurate refugia predictions. With these predictions, efficient action may be taken to protect what is still alive and innovate upon what we've lost.
Thank you, Isabella.